Hi there, everyone. You're probably wondering why I'm taking a video of a carton of eggs. It's a connection to the mole video that you watched yesterday. The whole point of the unit, the mole, is so that we can count a lot of atoms as one group, right? If I were to count all of these eggs, there are a dozen eggs, 12 eggs. But I can call it a dozen that allows me to count amounts of eggs a little bit faster. But the thing is that we don't have anything in the lab that can measure the number of molecules. All we have are scales. So if we want to count molecules faster, we're going to count them by weighing. And if we want to count millions and millions of molecules, we just need to weigh them. You see, if we find out how much 1 dozen eggs is, and we know that a dozen means 12, then if we have 2 dozen eggs, we know exactly how much that would count. That would weigh in terms of mass. And that works fine for larger things. Like if I wanted to count however many marshmallows there are in this package, I can count the marshmallows pretty easily because they're giant. But what if I had smaller marshmallows? I don't want to count how many marshmallows are in that bag because they're too small and it would take me a long time. And what if I had a much larger bag? Because this really isn't very many marshmallows. If I could weigh them and I knew how much some amount of marshmallows were, like 10 marshmallows or a dozen marshmallows or a mole of marshmallows, then I could just take the mass and multiply it by the weight and find out how many marshmallows I had. And this comes it becomes more important because M&Ms are smaller than marshmallows, and molecules are way, way smaller than M&Ms. So if we want to count a lot of things, counting by weighing them is going to be a lot easier. So that's what we're going to do today. We're going to count by weighing. But instead of counting in a dozen or a pair or a gross, like they weigh for large things, or a ream of paper, we're going to count them by moles.
Hi, everybody. This is Dr. Bower-Phipps. I'm here to explain homework 2 from Unit 8 on moles. Here we're going to count by weighing the gram molar mass of substances. That's what it's called. So because we want to count how much of a substance we have, we never want to count individual molecules. They're way too small. We're going to count them in a group. We could count by dozens, but that's really not enough. We're going to count by moles, right? Remember the 6.02 times 10 to the 23rd. But all atoms come in different sizes. Remember, we had a unit back on that in periodic trends where they had different layers and different protons and all kinds of stuff. So they're all different sizes. And so every kind of atom has a different mass. All of that is on the periodic table. So I'm going to get my periodic table out and find it in the classwork tab under the resource library. And here's our periodic table. We're going to need the information that's there. The other thing you're going to need for today's work is a calculator. So I have a link for a calculator available here. So I'm going to open up the calculator in my other window. Okay. So the periodic table, here's a little clip of the periodic table. There's carbon, the 6 on top, right? That is our atomic number, right? Atomic number. C is the symbol. The atomic number tells us how many protons. And then 12.01, that's the atomic mass. That means that 1 mole of carbon atoms is 12.01 grams, right? 12.01 grams. And here on the bottom, the word carbon tells you the full element name. You never have to memorize it, right? It's like the phone book. So if we just have one kind of element, right? So if we just have carbon atoms or just have hydrogen, we can use the periodic table and we don't need a calculator to know the mass of 1 mole of atoms, right? 1 mole of atoms, that's 6.02 times 10 to the 23rd atoms. So if we're looking at, let's see, hydrogen atoms, 1 mole of hydrogen atoms is going to be 1.01. 1 mole of chromium atoms is going to be 52.00 grams. 1 mole of aluminum atoms is 26.98 grams. So the periodic table can tell us what 1 mole of any element is. But what if there's more than one kind of atom? Like if we have a compound, we're going to do a calculation called the gram molar mass. And it's pretty easy. So let's take water for our first example. if we're going to do this calculation, we have to know the formula. So the formula of water is H2O. That tells us that we have 2 hydrogen atoms and 1 oxygen atom, because the little 2 right there tells us we have 2 hydrogens and 1 oxygen. So here's how we do the work. We have hydrogens, we have 2 hydrogens. We have oxygens, we have 1 oxygens. Then we multiply however many atoms we have by the gram molar mass, or the atomic mass from the periodic table. So we go back to hydrogen. Hydrogen is 1.01. So we put 1.01 here, and we multiply 2 times 1.01 to get 2.02. This one is easy. I don't even need to use the calculator. There's 1 oxygen. So to find this 16.00, I had to go to the periodic table and look at oxygen. Oxygen is 16.00. So I went back here and put in my 16.00. 1 times 16 is 16. But because all these things are in the same formula, now I need to add them together. So I take 2.02 plus 16.00, and I get 18.0 grams. That means 1 mole of water molecules weighs 18.02 grams. Not too bad, right? Let's try some more examples. What about propane? Propane is the gas that we use in tanks, like if you have a gas grill at home. The formula for propane is C3H8. So we set this up saying, all right, we have C's there, and there are 3 of them. We have H's there, and there are 8 of them. Now we need to multiply these by the mass of carbon and hydrogen. So I take 3 times, let's find out what it is for carbon. For carbon, it's 12.01. So 3 times 12.01 equals something. 3 times 12.01 equals 36.03. 36.03. All right, next up I have my hydrogens. I have 8 of them times, using my periodic table, here's hydrogen, 8 times 1.01 equals 8.08. I did that one in my head, but you can always use the calculator to double check. Now, we're going to add them up. 36.03 plus 8.08. I'm going to use my calculator. 36.03 plus 8.08. And then I hit equals 44.11. 44.11 grams equals 1 mole. That's my answer. Not so bad, right? All right, let's do a couple more problems. If you turn on an air conditioner this summer, it may contain Freon, the chemical that turns the air colder. The formula for Freon is CCl2F2. And if we want to find the gram molar mass of 1 mole of Freon, we do the same thing, right? We have carbons. There's 1 carbon. We have chlorine. There are 2 chlorines. And we have fluorine. There are 2 fluorines. So now I'm going to multiply these by the masses on the periodic table. Carbon is 12.01. 12.01. Chlorine is 35.45. 35.45. And fluorine is 19.00. So this one is easy to do. 12.01. 2 times 35.45. 2 times 35.45 is 70.9. 70.9. And now 2 times 19. 2 times 19 is 38. 38.0. Okay. The last step is to add them all up, right? 12.01 plus 70.9 plus 38.0. Okay. 38.0 plus 70.9 plus 12.01 equals 120.91. 120.91 grams equals 1 mole. Yay! Okay, ready for the third level of difficulty? Here we go. In the summertime, I like to garden, especially tomatoes. They're so good. To make my tomatoes grow well, I use a calcium fertilizer that is the formula calcium nitrate, CaNO3 This formula is a little bit harder. Now we have that family in parentheses for the nitrate. So let's count them. We have Ca, and we have N, and we have O. The Ca, right, there's no number next to it, so there's just one Ca. The N, remember this is in parentheses, and there's a number outside the parentheses, so there are 2 times 1 nitrogen for a total of 2 nitrogens, 2 times 1. And oxygen, there is a little number there. There's a 3. Remember, they multiply. 2 times 3 is 6 oxygens. That was the hard part. Now the rest is the same. Calcium is 40.08. 40.08. Nitrogen is 14.01. Oxygen is 16.00. I remember that from before. Okay, now I'm going to do 6 times 16. 6 times 16, and I get 96. 96.0. 2 times 1401 is 28.02, and 1 times 4008 is 40.08. So that means now I'm going to add these 3 things together. Okay. 40.08 plus 28.02 plus 96.0. All right. 96.0 plus 28.02 plus 40.08, and I get 164.1. 164.1 grams equals 1 mole. Awesome. Cool. Well, that's it. If you still need help, you can check out this other video with somebody else explaining the same thing. Here are 1, 2, 3, 4, 5 practice problems for you to try. Good luck. I'll see you soon.